Hello everyone, how's life? Jacob here from the Linux Cafe. This is the 11th video. Day 11 of our C programming course. We're going to talk about actually pointers in C. This is the first video which we're going to talk about pointers in, and I hope uh, you're watching the videos. Anyway, so this is the first video. We're going to have 3 to 4 videos or perhaps more on pointers because pointers are super important in C. I think the most important concept in C is pointers, okay? It's very important for you to understand how pointers work. You're going to see and work a lot of them actually in the programs you read, you write. You're going to need them, okay? So that's it. This photo is generated by AI 30 minutes ago, and you can look at it like the RAM in your system. For example, if this is the RAM, you know, the whole um, image here. If this is the RAM, the whole area, it has some segments. It has some segments. I mean, this is the first slot or the first segment or the first part of the RAM. This is the second part. This is the third part, the fourth part, the fifth part, and it has many more parts. Okay, so and each part is dynamic. Each part, its size is dynamic. For example, this one can be 1 byte. This one can be, I don't know, 32 bytes. This one can be 64 bytes. This one can be, I don't know, 5 bits. I don't know. This one can be more. And they vary, you know, they're different. Some of them are dynamically allocated. Some of them are statically allocated by actually the variables we define on the stack segment, okay, and not the heap segment, because they're two different concepts. And yeah, so each of them is a segment, okay? So, for example, let's close the image and let's talk about this thing. For example, if I say int first equals 5, so now here we know that we have an integer which allocates 4 bytes for us. It allocates 4 bytes, which is 32 bits. Okay, so here, oh sorry, here I said it's 32 bytes. Okay, it can't be 32 bytes, okay, no one's stopping us, but we must dynamically allocate it. But for the real world example, this is 4 bytes, okay, which is 32 bits. I just messed up with the words. I forgot the correct vocab to use. And this takes 4 bytes for us to hold an integer. But when I say char first, no, not first anymore, char a, like this, my keyboard just crashed, sorry. You must beg my pardon. My keyboard just crashed. I'm just sticking the button again. Okay. Here when I say the char a equals a, so we know that this is a character which takes 1 byte, or simply 8 bits. 8 bits. So everything in memory has a size. And we can find out the size, as I told you, using the size of function. So here we say, for example, zu, size of what? Size of, for example, char. So now we expect to see sorry for the noise. So we expect to see 1 and we see 1. Sorry. Okay. So we expect to see 1 and we see 1 because each char is 1 byte. And if I say, for example, int we get 4. It's 4 bytes. And if I say float, what do you think we'll get? Oh, sorry. Tmax is a shitty thing. If I say float, it's still 4. But if I say double, it may be 8. Okay. By the way, so each of them has a size in memory. And the actually the fact of pointers, the concept of pointers, is that I can have a real pointer, to one of these sections in memory, to this one, to this one, to this one, and wherever I want, perhaps wherever I want. Okay, so this is what pointers are. For example, and actually the way we can define them is a little weird. This is the syntax. We must say the data type of, I mean, for example, the data type of the variable or of the data section which the pointer is going to point to. For example, the data type, the asterisk, which here, this means that this is a pointer, and then we're going to specify the name. For example, I specify it as the int pointer, or simply you'll see a lot this ptr in books, and it equals to first. But how is it going to be equal to first? I mean, how is it going to point to first? Now this is completely wrong. Okay, this is wrong. Let's first talk about the two operators we have. We have two operators with pointers. First is the ampersand, which means the address of, and the asterisk, which has two meanings: for defining the pointer, as I told you, and for reading the value of that address. Done? I think you get what I mean. Now, let's talk about some examples so you can see this in action. For example, here I can say printf %p for pointer \n, and I can say the ampersand of first, and I can say again %p, the ampersand of a. So what we'll get? So we get two different addresses. So this is the address in memory. For example, this is this number here, which is not clear. AI couldn't generate it correctly. This is the number here. This is for this segment, okay? This is the address of first, where 5 resides in. So this is the section in memory, its address is this, and the data it's holding is this, it's 5. And the next segment, the next section, its address is this one, okay? 773 here, okay? So, and it holds the character A, and it's only 1 byte. This is 1 byte, this is 4 bytes, okay? And of course I can say printf %d for decimal, and I can say the asterisk of first, coffee break, sorry. I can say the asterisk of first, because as I told you, it has two meanings. Oh, sorry, what am I doing? I forgot that first isn't a pointer. Sorry, my bad. Now if I say, for example, int, as I told you how we can define it, int pointer, so I'm saying that this is a pointer to int, okay, a pointer to int, and its name is ptr, and it's pointing to the address of first, of course, okay, it's pointing to this address, this address. So now let's show you something. Percent %p, another percent %p. This is for the pointer. This is for the variable. If I say the ampersand of ptr, what do you think we'll get? So we get two different things. Don't forget this. We get two different things. We get two different addresses. Because, for example, the pointer variable is defined here in the memory, we don't know, and it's pointing to here. So this is in another section, okay? They're not the same. The pointer has its own memory allocated. It's usually 8 bytes, okay? A pointer is 8 bytes, okay? And yeah, so the addresses are different. Let's see what we'll get here. And now you can see that they're the same. They're both the same. The addresses look like the same. Okay, look like each other. So why? Because here I'm printing the ampersand first, which is the address of first, and then I'm printing the PTR itself. And because PTR is now pointing to first, so it's holding the address of first. So now you learn that PTR and ampersand PTR are two different things. Okay, ampersand PTR means the address of the PTR itself, but PTR means the address that PTR is pointing to. So don't forget this. You can write this down so you can distinguish and you can realize what's the difference. So now if I say printf %d ptr value, I can say the asterisk of ptr. So here the asterisk has the second meaning for reading the value of that address. So what do you expect to see? You're going to see what? You're going to see 5, because now it's printing the value of that address. It's 5. Now if I say asterisk ptr equals 14, we get 14 because the value is changed. And for you guys to feel what it actually means, I said that the address, the value of the address is changed. So now if I also print the first itself, it's 14 as well, because this is a reference. Actually, this is a reference to first. So if I touch its value, the first is going to change, of course, because we are changing the value of what? The variable first. The addresses are the same, as you can see. Each time the addresses are the same. The addresses are the first. What did I say? The addresses are the same. Okay, so they're actually one segment, one place. So if I change the value, it successfully changes the value of that address. So these are the simple things we can do with pointers. And why do we use pointers? Where are they used? What is the reason that we're going to use pointers in our program? We're going to explain it more and more. Okay, you will feel it, what I mean. And actually, this is the same with other data types. For example, we have a pointer to a float fptr, for example. We can have a char, as you've seen, for example, in defining a string. We can say str and start just typing. My name. What happened to my name? Okay. And of course we can have a simple PTR, for example CPTR, pointer to a character. We can have, I don't know, double, we can have int, we can have void. I will record a separate video for that. Yeah, we need to talk a lot about it, you know. It has many details and many things to say, many actually a little tricky castings in the program, so void is dangerous. We're going to talk about it more, a lot. A separate video for void. Void PTR. And yeah, so now you guys know about pointers. Let's define the first array in a previous video. For example, here we can say, I don't know, this is, no, let's say something. What is black and blue and dead all over? So the answer is Batman. If you're curious, okay, leave it. Batman. If you watch the movie. By the way, now when I say I have a pointer to a character, what I mean, let's just delete these. So when I say I have a pointer to a character, means that I have a pointer like this. For example, if the array is in this segment, in this section, I have a pointer to this section, to the first index of the array, which is W. And I've told you in the previous video how is it going to find out where the string is going to finish, okay, using the null char. So here I say, now you can understand what I mean by saying ampersand r 0, true. Now if I say printf %p backslash n, if I say ptr and the ampersand of r0, you can see that they're the same. Look, they're both the same. So this is now a pointer to this section, to this index. So you can check everything you want, you're curious of, with this. So now, if I say printf %d ptr, of course I'm going to get w, and I can change it. Sorry if I have a typo. So, oh, my bad. So here we can see that this is W here, it's pointing to this, and I can change the value using the pointer, and when I print the actual data, it is changed. Look, so what is no what anymore, it's rat, by the way. And yeah, we can also do arithmetics on pointers. I will talk about it more in the next videos. Thanks for watching. This was the first video about pointers. I hope you understand I'm going to take quizzes in the channel. Thanks for following up, and see you in the next video. Goodbye.